All right, well, happy Wednesday. We're finishing up loops, so this chapter then should be due the following Monday. Did I have that right? Is that in here already? Chapter 4? Did I put that in? I did. Good. So loops chapter again with your iBooks next end of Monday, end of next Monday. I didn't put the scores in yet for the first three chapters. I'll do that after my next class when I'm hanging out in my office. I'll put those in for you. So did have an extra day maybe there. Should be fine. Um, yeah, everything going pretty well. Sweet. Let's so this project was week 4 loops. I'm going to start a new project, but we got through regular loops, we got through loops within loops, right? We did for loops, we did while loops, we did validation loops, right? That said, hey, as long as you're giving me a value that I want, right? You're stuck in here, or I'm sorry, as long as you're giving me not a value that I want, you're stuck in the loop. We're going to only let you out of the loop if the value is good. Um, we did those. We did it with numeric values. We did it with characters. Works out pretty well. You can do it with strings as well. Um, so lots of fun with loops. We're going to use loops here on out because it's a nice way to just repeat the code, keep something happening until we're done with it. Right. And our next project was loops based. Had a couple loops within loops and silly loops for things. Um, Again, the goal of that one is not meant to be crazy difficult here. It's to just practice doing loops in a way where I give you less help. Right? That's sort of the idea here. Got the labs practice. So at the end of this, you should be pretty tired of loops here, or pretty familiar with loops, I guess I should say is a better way to put it here. So we start up a new project. This will be week 5 loops here. Make sure it's in my repository so we can commit and push. I'll add my namespace. I keep calling. All right. And get rid of some of this garbage stuff here. So the next thing we want to look at here, when we get to loops, there's some fun keywords here that you can use with loops. Break and continue. I really dislike these, so I will almost never use them. Um, Honestly, the only reason is that it just makes it harder for me to follow the code. And they're perfectly fine, and people love them and use them a lot here. Um, but we're going to look at them and see what they do. They interrupt the flow of the loop. Okay, is all that happens. So one of the things we talked about, I think, right, is when we make a loop, you don't want it to run forever. Right? That's an infinite loop, right? So I say while true, I now have an infinite loop here, and we can see out. I don't know, how about maybe we'll like a number here? So int number is 1. We'll see out the number and line, and then you can do this cute thing here. If you put a plus plus here, do you look at these pre-increment and post-increment operators, plus plus and minus minus? Or so this one updates the value after it's used, so it uses the value 1 and then it adds 1 to it. Right? If I put it beforehand, it'll add 1 and then it'll use the value. And I start counting at 2. Look a little silly here. But now I've got an infinite loop because I put while true. So it's never not true. And eventually, if we let this sit for long enough, we'd get to like the 2.1 billion max number, and then we'd add 1 to that, and the C++ would get confused, and we go negative again, and then we start counting negative 2 out some billion up to 0 and to 2 billion again. I don't think we want to sit here that long. So for what it's worth here, the computer is really slow when it comes to output. So putting something on the screen is a very slow operation, right? We've only gotten to 55,000 operations here, right? And that was with me talking for a little while here. Oops, I killed it. You can also hit the stop button. I did Control C to kill it. You can also come and stop your debugger here. So if you wanted to see how fast this thing can count, right, by not printing every single option here, so we can say, hey, if my number, how about modulus 1,000 is 0, then we should do the cout thing. So we're still adding. Oops, I'm sorry. I need to do. Oh man. Okay, so do this to the number. I can't have the plus plus inside here because it will never add, right? Because 1,000 is never true. It'll never add 1 to number. So we'll cout the number, and after this, then we'll take number plus plus. So we lose our little shortcut here, but that's okay. So we're always going to add 1 here, and only if it's evenly divisible by 1,000 will we print. So now you'll see it can add 1 really fast. right? Now we're up pretty quick here, counting by thousands. So the slow part wasn't the adding one. The slow part was printing it to the screen. So you can see it's still ridiculously fast here. If we want to go, you know, let's do by a million, maybe three. Count by millions here. Right, that should only take 2,000 some operations to get to 2 billion. That's going pretty quick. And then we get negative again, right? So again, it's adding one millions and millions and millions of times here. It's added one over 2 billion times already, right? Because we've wrapped around 4 billion times now. So the arithmetic part is very fast, right? It's the display part that's slow for what it's worth here. Um, but infinite loops are silly, right? No one wants an infinite loop. So what you can do is you can use a keyword here to stop your loop. And this is where I dislike them here. So we can say, hey, what if my number is equal to, is it int max? You can use this keyword called break. And what break does is it breaks the loop. Breaks the loop. Oh my goodness. Breaks. Don't judge my spelling. Um, English is hard, right? We've got words that sound the same with different meanings, and I'm dumb. So, all right. So breaks the loop, ends it, or stops it completely. So whatever line you're on, it immediately just says, okay, go to the end of your loop body, and then we can see out the loop is done, right? So when we get to our max integer, we should stop here. That should go pretty quick, right? We can add one a lot of times. And our loop is done because we hit our break keyword. So while the condition never became untrue, never became false, break doesn't care. You hit a break, your loop stops. So when I'm reading a loop and I say, okay, I start my loop, here's my curly brace, I'm going to go from the top to the bottom, and then I'm going to come back, break says, no, oh, we got other ideas. Game over, loop's done. And that's why I dislike it, because it's jarring to follow the code, be like, oh, I'm not going to do what I usually do with a loop, I'm going to stop. And that's all. And some people really like them, and that's fine here. I just try not to use them here because I'd rather put my condition here, like while the number's not the max int, do something, because then I don't need to add a break. And I can see when the loop is going to stop here rather than having to read halfway through my loop to find out, oh, it's going to break if it gets to this. So uh, that's all. It does some silly stuff here. Excuse me. The other thing you can do with loops and those fun keywords and controlling what happens in your loop is you can use a continue keyword. So if we wanted, let's do a different loop here. So we'll say, how about for int, I'm sorry? I? Sure, I hate I, but that's okay. I is 0. I is less than, let's go 100 here. I plus plus. I just don't like I because I don't know. I feel like we should have more meaning to it, but most people use I all the time. I'm just weird. Um, so if we only want to print the odd numbers here, we can say, hey, if my I modulus 2 is 0 here, which is the not case, what I want to do is I want to continue this loop. So continue says jump back to the loop header. So stop going down line by line by line, just go back to the top. That's all it does. So it skips everything that's after here. So then after that, I would see out I and an end line here. So, oh, we probably don't want that loop to happen first. That one's too long, sorry. Let's put this one at the top, maybe. Let's go by a billion, I guess. That'll be a lot faster. Here, I'll put my loop back. So we'll just count twice. Oh no, it was 100 million. Oh man. Loop is done. Oh, I never got my output. Did I do it wrong? I did it wrong here. I'm too tired. I need more coffee. Why did it not give me my... I did? Did I... I closed it too soon. I did. Told you I need a little more coffee. Yeah, we get the odd numbers. Again, not very exciting here. We could have just said if it's odd print here, Now, sometimes a continue is helpful because you might have like 50 more lines of stuff in your loop that you want to skip, and that's much faster. Again, you could just put it in an if block though. Let's say if it's true, do this, and then no other code runs, and then it comes back to the header here. And again, to me, it's visually jarring to have to try and follow loop code with a continue in it. So, but you can use them. You're welcome to do it. The book has some silly examples where you do breaks and continues, and that's fine. Right? They're tools in your toolkit. You're welcome to use them. Um, they don't allow you to do anything that you can't do without them. So they're just shortcuts. Right? We could use a continue just with an if else. Right? So instead of having to use the continue keyword, we just put an if this is true, and then if it's not true, everything else happens. Right? With the break, that just needs to go in the condition. Right? If you want it to break in the middle, well, then you have to do a little check. Hey, did we meet our condition in the middle? Right? But you can still have that in your while condition here. So they don't give us new things to do. They just give us some shortcuts, is all, with break and continue. All right. Variable name scope. This one's important here. So scope is a funny word here. It's one of our technical terms. It's all about the block of code here determines a scope. So where you declare a variable determines its scope. So if you declare a variable inside of a loop here, it's not accessible outside of the loop. It's only accessible within its block of code. So, and I think we looked at trying to set values and things when we did our first loops last week. We didn't do too much here. We had to declare it outside the loop so you can set it inside the loop, and then it still has a value when you're done with it here. So because number exists here, when I'm done, I can see out number, and number still exists because we didn't create it inside the loop. With I only exist within the loop. I can't output I after the loop is done because it doesn't exist. It says I is undefined. It only exists within this loop scope, the scope of the loop here. So it's not accessible outside of that. You can with for loops, you can declare an I or whatever value you want and then just set it within the loop here. Most people don't do that, right? If you want a for loop, usually you want to just use a temporary counting value here. Now, weird stuff happens when we have int I here and int I here. We'll build errors. We get local variable I, uninitialized local variable I used. It says I was never initialized, it was never given a value. Because we have an I within this scope, when we use I, it uses this scoped I, not the outer scoped I, which gets awfully confusing. So generally you don't want two variables with the same name. That's just a pretty good rule of thumb here. But if we were to set this thing to 0 here, when we print down here, it'll still be 0. Right? And our program will run and be happy. It won't be the 100. Oh, there it is. So still 0, because it's a different value for I. And if you're not sure, you can put it in debug mode. Okay, let me go add another I0 here. That's still awfully slow. So in debug mode, oh, now it's taking like a little second here to add 100 million at a time. What was that? Maybe less than a second for the computer to add 100 million. All right, now we're in debug mode. Right, this debugger is your favorite tool to be your best friend for why is my program not doing what it's supposed to be doing? For you to get rid of the bugs, to debug the program. It's a cute term, right? We have I here. This I doesn't exist because it's no longer within scope of our debugger. So if we paused within here, then we would see it. I think, can I drag it back? I think I can drag it back here. Hey, look at that. Sometimes that works. You can go back a couple lines. It doesn't always work well, but sometimes you can change, hey, go back up a couple lines, like rewind time, which is kind of fun. Now we see, hey, I've got I is 100 and I is 0. I've got two different I's, and it's a little bit confusing here, right? But you can see both of them, and then I continue on, and then back to my loop. Loop stops. And so when it goes out of scope, it's no longer visible as a local variable here, because it's not accessible anymore. So it's not going to show me what the value is. So use the debugger. That's fantastic here. Yeah, for loops. Sure. Okay. Awesome. Enumerations. So this is a fun way of putting names to values. That's why we like it, because it gives me names and values. So you can use a type of enum here, and then whatever we want to call it. So what is this type of enum here? Um, so their fun little example was light states. These are terrible. I hate some of their sample code here, but I didn't write it. That's okay. So I can make fun of it. All right. So with an enum, it's really just a shortcut way for me to put names to values so that anytime I want to reference a light state here, I can say, hey, this is the red, green, yep. Why red, green, yellow? I guess it does. Okay, if you start with red, it goes in that order, but it's a weird order to start in. Red's at the top and yellow's in the middle and green's at the bottom? Yeah, but so like we're saying it out of, I don't know. Okay. It's beside the point. So if I want to pass a light state around here, I want to say like, hey, I want to tell my car to stop while the light state is red here, right? I can use this value of ls red here, and I can set other values in my code here. I can have a light state value, and it can be a red, a green, a yellow, or a done. I don't know what done is here. Maybe it's like some sort of racetrack here. I don't know. Uh, so like my light state, so a light state for current light state equals ls red. And while my current light state is equal to ls red. Okay, so I can put like a name here. Hey, this is red. I guess I should, this was SciBooks chapter 4. All right, I'll even give you the URL here. I'm going to try and be good here, right? If you use someone else's code, we should cite our source, right? Even for one line, right? That's fair. Uh, so, all right, if it's red, I don't do something here. And how about we print out here, wait at the red light. And then I'm just going to do a really dumb thing. It's okay. We're just going to count to 1 billion to make my computer be slow. There's better ways to do it, I promise. We just haven't got there yet. And I don't want to Google that. So int I is 0, I is less than 1,000, million, 1 billion. And then we can set my current light state to light state green. And that should stop my loop eventually. And then we can see out green means go. All right. So it should take a brief second here, right, to pause. Wait to the red light, and now we got a green means go because we made the computer waste 1 billion operations here. Thankfully, it was pretty quick. Is that very exciting? It's very exciting. So, but the nice thing here is I have names to my variables. Right? We talked about using constant values before. Right? You have a name to a variable. Now, what's nice about an enum is I don't need to have like this constant is 0, this constant's 1, this constant's 2, this constant's 3, and remember any of that and then store them as integers. Because we could do that, right? We could say, hey, I've got a constant int green is 0, constant int yellow is 1, constant int red is 2. Right? We can have some constant values here for these, but then if I want to store what the value of the light is, it's an integer, current light, right? I can assign it, hey, it's green here, but it's the type of integer. So it's possible to give it something that is not a valid light state here in my code, right? So by having an enum, the only possible values you can give it are red, green, yellow, and done. You can't give it 27 by mistake. So it's a safer way here, and then it's even quicker, right? You don't have to do a lot of typing here. And then I don't know if you noticed when you hover over it, it tells you, hey, red is 0, green is 1, yellow is 2, done is 3. It actually behind the scenes is storing integer values for them here. but we don't have to worry about any of that stuff here. So they actually are integers, but we don't need to give them integer values and things. And then we get a nice restricted, hey, you can only be set to one of these things here. Like if I try and set it to 27, it's no good, which is nice, right? We want that sort of protection here to make sure we can't get to a bad state here. So we'll set it back to red here, and we can use that value. So it's really nice to be able to loop through or have these values and use them here like that. All right. So that was our enums. That's our state machine. Very exciting. So you can go through those examples here. All right. I think that covers all the pieces from loops. Very cool. Did we get through all of them? We did developing programs incrementally. Hopefully you've seen this. Ideally, we do this when we tackle a big program. We want to do little bits at a time. It's hard because nothing we've really done has been that big yet. But eventually we'll get there to bigger programs where we're going to have, okay, here's a little bit, and here's a little bit, and here's a little bit. We'll just get something there. It doesn't need to be finished yet. We want something that runs. Test out a little bit that runs and add more to it. So we'll get into some of those as we go. I wanted to do one more shape here because I'm quite fond of shapes. Oh, actually, no, I wanted to do a dice example here because I really like dice and they make me happy. Um, Now, we're not going to be able to do all of the really cool things that I want to do because we don't have ways of storing information yet that aren't tediously slow. But after I'm done recording, I'm going to show you a video from a really cool YouTuber, Stand Up Maths, that talks about some dice statistics here. Um, and eventually we can do the sorts of things he's doing in code here in C++. We just aren't quite there yet. We need how many more weeks? We need to get to arrays and vectors before we can start doing what he's doing here. So in a couple more weeks, we'll be able to tackle his full problem here. It'll be a little bit of fun. So one of the things we can do with dice here is we can sort of see essentially how random these random values are. Right? We can test it out. So if we roll, pretend we have a six-sided die, we'll pick a number 1 to 6. We'll do it a bunch of times and we'll look at the distribution. If it's actually random, the distribution should be pretty even, right? It won't be exactly even because it should be random. Some will have more, some will have less, but it should be close, right? So if we take a sample of 10 rolls, it's going to be bad. If we do a sample of 100 rolls, it'll look better. 1,000 rolls, even better. 1,000,000 rolls, even better, right? We'll get closer and closer and closer to that nice even distribution the more samples we take. You're all good at math, right? Did anybody take a stats class, or did you get right, like bypass stats and get right into calculus? You had stats?
No, I bypassed.
You bypassed it. Okay. You had stats? No? Stats was my favorite math class. They, by and large, the most practical math class for software engineering, in my opinion. And my opinion means very little, but that's okay. So we want to do some dice statistics here. So we're going to generate a bunch of random values here. So I need a way to count how many times each of those showed up, right? So we'll have an int count of ones, starts off at 0. Count of twos, starts off at 0. And I got tired of typing already here, so I'm just going to go copy paste 3s, 4s, 5s, and 6s. Right, and we'll just fix these here. 3s, 4s, 5s, and 6s. Okay. And if we want to do something some number of times, we want a for loop, right? Because we know how many times we're going to do it here. Or we can even ask the user, right? Why not? So we'll have an int number of rolls equals, I will just start it here and we see out how many times do you want to roll. Do you want to roll? And then line, and then we can see my number of rolls, and then for int roll is 0, roll is less than my number of rolls, roll plus plus. Again, I'm not actually doing anything with this roll value here, but I like putting a word to it here. This is what we're pretending to simulate here. We'll pick a random number, right? So we need int random value is rand, and then we want modulus 6, will give me a random number between 0 and 5, right? And then I can add 1 to it to get 1 to 6, right? Plus 1. And then, hey, if my random value is equal to 1, then I'll take my count of 1s plus plus. And this is where it gets really tedious. Once we get to the arrays bit, I can show you a shortcut so you don't feel bad about yourself having to copy paste a bunch of code here. My random value is equal to 2, value 2, count of twos. Oh my goodness, not see out. Count of twos. Plus plus. Right, and this one I can copy paste now for threes, fours, and fives, and sixes. 1, 2, 3, 4, 5. And we could just have this be an else, because if it's not a 1, 2, 3, 4, or 5, it's got to be a 6 here. I'm going to leave it here because we're going to change it in just a second. I'm going to go expand on this. So um, either way works here, right? You can do whatever you want here. Fives, fours, threes, right? And then when we're done here, we can see out count ones is the count of ones. Oh man. And probably an end line, right? Do you want to do a percentage here of rolls or just have the counts? We should do percentage, right? Oh, okay, just the counts. Sure, we can do just the counts. Ones and twos and threes. The rest is threes, fours, fives, and sixes, and then make sure we change our variables here. So the downside with copy pasting is it's possible you type the wrong variable name. Do it all the or forget to update a variable name here. You do that all the time, but sometimes it's easier than trying to type it all out. So I think we got it all right here. So let's give it a shot. How many times should we try? Four. I heard four, right? So we got two fives and two sixes. Very exciting. I'm just in string pause. If you just CN on something, your program just waits. So it'll just sit there for a second for you to press a key, essentially. Let's try it again. How many times should we roll now? Five? Right? Oh, we're getting the same. We got to seed it, right? So let's go back and seed. We have to include time or something. What was it? C time? Yeah. C time, and then we have to do a srand of time of 0. Is that right? I'm trying to remember what we did last time, which was when I had to Google it last time. Trying to remember how well. I think that'll work a little bit better. All right, let's pick another number. Let's do 5 again. Make sure. All right, now we're getting different values. Life is good. So let's do a bigger number. All right, see if we get a better distribution. 15. All right, we got a lot of threes, no ones. Let's go even higher, like in the hundreds. 200. All right. 26, 39. So they're relatively close, right? And if we do it, say, like 100,000 times, they're even closer. It's still off a little bit here, but within 100, which is like less than 1% difference of each. Feels pretty good, feels pretty random, right? All right, awesome. So we can do fun stuff like that with loops here. Okay, the YouTube video is about 25 minutes long here, so I can stop the recording. I can't record another person's YouTube video because if I post their recording of it on YouTube, they'll take mine down or mute it all out or do weird stuff like that here. So I'll post the link here. I'll show you what it is. It's stand up maths. Here we go. This I don't want it in your weird viewer, Bing. No, I want it on YouTube.
This moment feels heavy.
Oh.
Medical facilities are
Stop. Okay, the unexpected logic behind rolling multiple dice and picking the highest. Those of you who aren't familiar with nerdy games like Dungeons and Dragons, that's rolling with advantage. So now you know. All right, so we'll watch this. When we get to arrays, we'll come back and we'll do this in code because it's fun and I like numbers. So if you're not into stats and numbers, that's okay. It might be a little bit boring, but it's really cool. And he does Python code. It's a little easier for math folks to do Python code than it is C++. Is anybody a math major? Math majors used to have to take 150, which was a weird choice, but we didn't have a Python class previously. So ideally now they're taking Python rather than C++ for math majors. So, okay, every now and then I get a math major. People want to get like into actuarial sciences and stuff and do fun mathy things. But all right, awesome. So we stop the recording. We'll watch this, and then we'll call it a day for loops and move on from there. Okay. Awesome.